Welcome in .Cool. October 4th, 1957, the first artificial satellite, Sputnik 1, was launched into space by the USSR. Sending the first satellite into space was a breakthrough achievement for humanity and the beginning of a new era. It was also the start of one of the most iconic battles in history between two superpowers. It was the beginning of the space race. As most historians agree, the Apollo 11 moon landing on July 20th, 1969, that put Neil Armstrong on the moon, put an end to the space race, despite the many successes that the Soviet Union had achieved. But soon everything will change as the world starts a new race in space: mining. Nations all over the world are thinking about mining the moon. China, India, Israel, the USA, Russia, all of them are trying to grab their own piece of the pie. Russia has already warned the USA against colonizing the moon, and now tensions between countries are rising. But is it really worth it? And just what is on the moon that is so precious? It's very possible that the moon could have large quantities of silicon, titanium, aluminium, water, precious metals, and helium-3. Today, we'll focus on helium-3 and why it's so important for us. Lunar missions from both the Soviet Union and the United States brought back lunar soil samples, which were found to contain helium-3. The biggest reason we need helium-3 is that it could help free the entire world from dependence on fossil fuels. Having enough helium-3 could help us achieve clean energy produced by fusion power. The most important discovery was a unique atomic structure of helium-3, and that it could be used as fuel for nuclear fusion. A nuclear power plant uses a nuclear reactor to produce heat. The water surrounding the reactor boils, becoming steam, which in turn rotates a turbine that produces electricity. Current nuclear reactors are using nuclear fission, in which uranium nuclei are split apart. Besides releasing energy, this reaction is also radioactive, and the radioactive waste which is produced needs to be stored in special secured underground stores for more than 40 years. Researchers have been designing a different type of nuclear reactor which could potentially provide an environmentally acceptable and safe solution to our long-term energy problems. In these reactors, light gases such as the hydrogen isotopes tritium and deuterium are used as fuel instead of uranium. When the nuclei fuse, a stable helium-4 isotope, a neutron, and atomic energy are created. This reaction does not produce radioactivity and nuclear waste. But there's a problem with this procedure. The first neutron that produced after the fusion is very difficult to contain and leads to significant energy loss. This is where helium-3 comes into play. From a helium-3 and deuterium fusion, there is no extra neutron created. Instead, the byproducts are a massive amount of atomic energy and a proton, which is easy to contain and wastes less energy. And on top of that, the helium-3 and deuterium reactions do not cause the surrounding material to become radioactive. Nuclear fusion reactors using helium-3 have the potential to provide a highly efficient form of nuclear power with no waste and no radiation. The building of the first fusion reactor has already begun, and in 2035, it's planned to be the world's first fully operational fusion reactor. So we have 15 years to manage the lack of helium-3. But why do we need to go to the moon to extract helium-3? Helium-3 is relatively rare on Earth and is produced from the radioactive decay of tritium, a byproduct of the maintenance of nuclear weapons. But this isn't enough to supply us with what we need. In fact, helium-3 on Earth has a very low natural abundance and a very high production cost. Helium-3 is emitted by the sun through solar winds, but our atmosphere prevents any of this from getting to Earth. Unlike Earth, which is protected by its magnetic field, the moon has been bombarded with large quantities of helium-3 for billions of years by the solar wind. It's been estimated that there are around 1,200,000 metric tons of helium-3 on the surface of the moon down to a depth of almost 10 feet. This makes helium-3 100 million times more abundant on the moon than it is on Earth. And since solar wind gases are weakly bound in the lunar regolith, it should also be relatively easy to extract them. Many scientists believe lunar deposits of helium-3 could provide us with all the power we need for 10,000 years. Researchers estimate that 25 tons of helium-3, which can fit in the cargo bay of one U.S. shuttlecraft, could power the United States for an entire year. This means helium-3 has a potential economic value of about $3 billion a ton, making it the only thing remotely economically viable to consider mining from the moon. The potential benefits of helium-3 are massive, and that's why the largest countries on the planet are planning to go to the moon, to helium-3. The United States' ambitious decade-long Artemis plan promises a human landing in 2024 and the establishment of a moon base that will allow long-duration crew stays for scientific, technological, and economic purposes by 2028. Furthermore, there is an aspiration for a gateway to orbit the moon and serve as a jumping-off point for astronauts who want to explore Earth's natural satellite. This gateway is also envisioned to serve Mars missions in the future. This massive plan will entail 37 launches of private and NASA rockets and a mixture of robotic and human landers. In 2019, the U.S. Space Agency awarded contracts to private space tech firms for the construction of a few of the first pieces of hardware that will be required for this colossal mission, such as the Gateway platform and the Lunar lander. NASA wants to get back to the moon by 2024 with its Artemis mission, which will cost $35 billion. That's almost 5% of the U.S. military defense budget for 2020. The steep cost of this expedition has been met with skepticism regarding the goal of getting humans on the moon by 2024. For now, the U.S. Space Agency plans to put the first humans on the moon before 2030. Across the Atlantic, Roscosmos, the Russian Federal Space Agency, has been very eager to show the world their ambitious plans for the creation of a lunar orbiting space station and a lunar base. Their plan includes developing a new super heavy booster that can carry up to 113 tons of cargo to low orbit and 29 tons to the lunar pole orbit. The Russian lunar orbit flight is scheduled to take place in 2029, and Russian cosmonauts will officially take their first steps on the moon in 2030, while the construction of the Russian lunar base will begin in 2034. Unlike the United States, Russia does not see the potential for industrial utilization of the celestial body. Instead, they claim the role of their lunar station will be used as a defense against comets and asteroids. Not surprisingly, China has been heavily investing in its lunar program while also researching the possibility of lunar mining. Their program took off in 2007 when China sent off a spacecraft to orbit the moon to collect data about the moon's geography. By 2013, China successfully completed Stage 3 of its lunar exploration program by soft landing their first probe, U2. On January 3, 2019, China's second lunar rover, U-22, landed on the moon and is now scanning the moon's far side. Incidentally, China was also the first country to grow a plant on the moon, inside the Chang'e 4 probe on January 7th. You can check out that video here, or you can find that video link in the description. In 2019, the Chinese National Space Administration talked about their interest in building a lunar base of their own on the south pole of the moon in about 10 years, while also planning to send off their first crewed mission before this. The scale and timing of China's lunar program can only highlight Beijing's ambition to rival the United States and Russia as a space power. There's a big question regarding this. Who really owns a moon? The Outer Space Treaty was signed in 1967 by the United States, Russia, and several other countries. The Outer Space Treaty doesn't ban military activities within space, military space forces, or the weaponization of space. However, it does prohibit the placement of weapons of mass destruction in space, including nuclear weapons. It also limits the use of the moon and all other celestial bodies to peaceful purposes only. It states that space should be free for exploration and use by all nations, but that no nation may claim sovereignty of outer space or any celestial body. It's mostly a non-armament treaty but has no real regulations when it comes to lunar and asteroid mining. Who will be the first to go to the moon and successfully mine it? Only time will tell. For now, we need to understand the future, and that future is coming right now. In a decade or so, space mining will become a reality, and all of us will witness history being made. It will be the beginning of a new age in humanity's history. We've put a lot of effort into this video, and we hope you enjoyed it. Thanks for watching.